Okay, so in this case, they tell us that we are looking at the graph of f prime. If you need to write that in big bold letters, write it in big bold letters so that you realize what you're looking at. If you want to write it in words, whatever you need to do to make sure that you know what you're looking at so that when you're addressing the questions, you can address them appropriately. It does tell us that it is a twice differentiable function. Sometimes it uses that terminology. So usually that means that they're going to ask you a question somewhere along the line about the second derivative. Not always, but sometimes. So just be aware of that when you see that terminology. From -3 to 4, it tells you specifically that it has horizontal tangents at -1. So I would go in there and I would draw the the horizontal tangent line, and you might want to draw a line there from the -1 to let you know that it's happening at that exact point, at +1 and at +3. So usually that means at some point in time those numbers are going to come into play. The areas of the region bounded by the x-axis in the graph of f prime on the intervals from -2 to 1 and 1 to 4 are 9 and 12 respectively. So I would take that information and I would put that on my graph as well. So between -2 and 1, that's that area under the curve here. So it's under the x-axis, so that's going to be a -9. And from 1 to 4, that's also under the x-axis, so that's going to be a -12. I would go ahead and just put those on my picture. Not entirely sure how I'm going to use them, but it does help to have that visual. We don't know about the area between -3 and -2. They didn't tell us. All right, let's look at A. Find all x coordinates at which f has a relative maximum. So like we did yesterday, before I even look at the graph, I want to establish in my head what the relationship between f having a maximum and f prime is. So I'm going to write it down in words. F has a relative maximum where f prime changes from what to what? From positive to negative. Therefore, at where positive, negative, that occurs at -2, at x equals -2. Okay, so let's see here. That is 1 point for identifying x equals -2 and 1 point for your answer with a reason. So I did the reason first because I think that just helps you focus on exactly what you're looking for on the graph, and hopefully keeps you from being distracted as to you don't just want to identify the maximum there at 1. That's where f prime has a maximum. That's not where f has a relative maximum. Okay, part B. On what open intervals is the graph of f both concave down and decreasing? So again, I'm going to start with the reason here. I'm going to start with the reasoning. F is concave down when f prime is decreasing. I'm looking at f prime, so I need that reasoning there. F is concave down when f prime is decreasing, and f is decreasing when f prime is negative. Therefore, f is concave down and decreasing for let's see here, where f prime is decreasing and negative. So negative, I'm negative between -2 and 4, so then I just need to pick out the intervals where it's decreasing. So from -2 to -1, and from 1 to 3. From -2 to -1 and 1 to 3 is where f prime is both decreasing and negative. Therefore, f is concave down and decreasing on those intervals. So 1 point for the intervals, 1 point for your reason. So pretty simple so far. We've got 4 points. That's almost half of what the problem's worth. That's a really, really good start. Part C, find the x-coordinates of all points of inflection for the graph of f. So again, let's remember we're looking at f prime. F has points of inflection where f prime has what? Maximums and minimums, or extrema. You can say it either way. I'm just going to say extrema so I can write it in one word instead of two. Therefore, at x equals, where's our extrema? -1, +1, and 3. It's -1, +1, and 3. So again, 1 point for your values, 1 point for your reason. Now, their reasoning was that because f prime changes from decreasing to increasing / increasing to decreasing, it's the same thing. Okay, I'm pretty sure that they will accept where f prime has maximums, minimums, or extrema, or where it changes from increasing, decreasing, vice versa. It's all saying the same thing. All right, let's look at D. So we've got 6 points so far, and I think y'all should feel pretty confident in those 6 points. Given that f of 1 equals 3, write an expression for f of x that involves an integral. So this is a lot of what we were doing yesterday. F of x is equal to, they gave us an initial value of 3 plus the integral from that initial value is at an x of 1. So 1 is your lower limit. We're looking for a general expression here. So x is our upper limit of f prime of, remember, we're supposed to use a different variable here. So it doesn't matter what you use. We don't have a unit of time here, but t is just a good, easy variable there to use when you're trying to mix up your variables. Okay? So you get 1 point for that expression right there. Then they ask you to find f of 4 and f of -2. So then it's just a matter of evaluating, right? F of 4 is equal to 3 plus the integral from 1 to 4 of f prime of t dt. So that's equal to 3 plus, remember the integral from 1 to 4 would be the area under the curve. So from 1 to 4, the area under the curve is -12. Because it's under the x-axis. So that's -9 for f of 4. And then they also want f of -2. So we've got 3 plus the integral from 1 to -2. Remember, they really, really like doing this. Okay? They love giving you one that's to the left of your starting point. So you have to make sure that you flip that interval over and put a negative in front of it. Okay, our limits weren't least to greatest, so we've got to make them least to greatest by flipping it over. Anytime you flip over your integral, then you change the sign, you put a negative in front of it. So from -2 to 1, that area under the curve was -9. but there's a negative in front of that, so we add it, so it's equal to 12. And that should, you can kind of check this, right? If f of negative 2 is 12, you know that f of 1 is equal to 3, so if you add the area under the curve between negative 2 until you get to 1, you should get to 3, right? So it's an area of negative 9, so 12 minus 9 is 3. So you should kind of logic through that. So that's a 3-point part there. So there's your 9 points. We discussed yesterday, just a reminder, don't necessarily box in your answers. I know it's tempting to. And in this problem, not really that big of a deal to box in your answers, but on some of them you really want to avoid it because you may think that what you box in is the final answer, but it's not necessarily the final answer. So if you don't box anything in, then the readers consider your whole body of work in that box, in the whole box that they give you there for part A, B, C, etc. So just don't box anything in unless you absolutely know it is the right answer.